Forget everything you knew about finding limits. So here, we're going to evaluate the limit as x goes to 4. So we do direct substitution, I guess don't forget that part, and we end up getting 0 over 0. So we're going to do this new thing called L'Hopital's rule. You'll notice I spelled it different than your book did. There's at least two accepted spellings. To do L'Hopital's rule, you have to do the derivative of the numerator and then the derivative of the denominator. Now be careful because this is not the quotient rule. We're not doing the derivative of this function. It's just a way to evaluate this particular limit. So we do the first derivative of each one. And in this case, we got 5 over 1, so that's the answer. We're done. So on this one, we're going to do direct substitution first. We always have to, because L'Hopital's rule only works when you get 0 over 0 or infinity over infinity. And in this case, we get 0 over 0 when we do direct substitution. So we're going to do the derivative of the numerator and the derivative of the denominator. So then we plug in the negative 2 and see what we get. And that's your answer. So here's another example. They're not only going to be polynomials whenever we do this. We do have to do direct substitution. Here we're going to see that we're going to get 0 over 0, which means we can use L'Hopital's rule. And so we do the derivative of the numerator and then the derivative of the denominator. And then we plug in 0 over 0. I'll speed this example up. Just remember, you do direct substitution. If you get 0 over 0 or infinity over infinity, then you can do L'Hopital's rule. To do that, you do the derivative of the numerator and then the derivative of the denominator, and then you evaluate. So again, we get 0 over 0, which means we need to do L'Hopital's rule again. So we're going to do the derivative of negative sine x and the derivative of 2x, and then you plug in 0, and that's your answer. For the next couple examples, we're going to look at when they go to infinity. And so on something like this, you're going to get infinity over infinity, which means we can do L'Hopital's rule. So we're going to do the derivative of the numerator and the derivative of the denominator. And then here, we're going to get 5 over infinity. So you got to remember something like this is going to be 0 because the denominator will get very large, and so the whole number goes to 0. So 0 is just your answer. On this one, we're gonna get infinity over infinity, and then we're gonna do the derivative of the numerator and the derivative of the denominator, and then we're gonna get infinity over infinity. So that's why I did this example for that reason and for the next reason. When we do L'Hopital's rule again, then we're going to get 14 over 10. So of course we have to simplify, but then we're done. Sometimes you do have to do L'Hopital's rule more than once. Now for this example, we're going to get infinity over infinity, and then we're going to do the derivative of the numerator and the derivative of the denominator, because that's L'Hopital's rule. So then we get infinity over 1, which is infinity. So the answer is infinity, but remember when we do limits and we get infinity, then our answer does not exist because it's unbounded.